Okay, guys, this is our last section, and it is short and sweet. And it's just some basic information about matrices. Just some information that you need for going on to some future classes. We talked a little bit about matrices before. We use them in Cramer's rule. And now we're just going to specifically give some general information about matrices themselves. So it's customary to use capital letters to name matrices. We've probably already said that. And we use subscript notation to name the elements of a matrix. Now, matrices are the size of a matrix is given by we call it row by column. So this is we count the number of rows, 1, 2, 3, 4, 5. These, I'm sure that's supposed to be dot, dot, dot. Probably just didn't transcribe well in the software. I don't know why else there'd be a big M there. Okay, but let's say this was just a row of values also. This would be a 1, 2, 3, 4, 5 by 1, 2, 3, 4. Okay, I'm sure these L's are also supposed to be dot, dot, dot. Weird. I see that happen sometimes. Okay, not that it matters. And each element is, we'd say like, look, this is the position that's in the first row, first column. This is in the first row, second column. First row, third column. Dot, dot, dot. First row, nth column, however many there are. This is in the second row, first column. This value's in the second row, second column, second row, third column, right? So this one's in the third row and the third column. This one's in the third row, but the second column. So that's the notation we use to identify each element and to identify the size of the matrix. Do row by column first, row by column. Okay, and then there are certain matrices that have special names. An n by n matrix is a square matrix. Now we're familiar with those because we had to have square matrices to find the determinants, right? So that's when the number of rows, of course, is equal to the number of columns. If you have a matrix with just one row, you call it a row matrix. If it has just one column, call it a column matrix. Two matrices are equal only if they have the same elements in the same position. So these two matrices are not equal matrices. Even though they've got the same elements in them, they're not in the same positions. So these matrices are not equal. Okay, so finding values that makes matrices equal. Find the values of the variables for which each statement is true, if possible. So that means right here, x has to be 2, y has to be 1, p has to be -1, and q has to be 0. That's the only way that those matrices can be equal. Over here, that's not possible. In order for matrices to be equal, they have to be the same size first. So that's just not possible. If we're going to add matrices, first of all, only matrices of the same size can be added, and then you just add the elements that are in corresponding positions. It's the simplest thing ever. If I'm going to add these matrices, because this is a 2 by 2, my answer is going to be a 2 by 2. If they're not the same size, you can't add them. And you just add the elements in corresponding positions. So 5 plus -4, -6 plus 6, 8 plus 8, 9 plus -3. Right? That's all there is to it. I'm telling you. Sweet. Okay, so this is going to be a 3 by 1, a 3 by 1, because each of these are 3 rows by 1 column. Just add corresponding positions. 2 plus -6, 5 plus 3, 8 plus 12. That's all there is to it. Now, here's another way you might see those instructions written. Okay, find A plus B if matrix A is this and B is that. Well, it's not possible. They're not the same size. So I can't do this addition. But once again, this is just another way you might see it written. So if it had been instructions like this, oh, then I could add them together. 5 plus 3 is 8. 8 plus 9. 6 plus 4. 2 plus 2. Right? But as written, not possible. Subtraction of matrices is the same thing. They're saying you just add the negative, but we don't even have to go, to that much thought. You just do what you would naturally want to do. Again, they got to be the same size, and they are. So I know my final matrix is going to be a 2 by 2. -5 minus -3. So -5 plus 3. 6 minus 2. 2 minus 5. And 4 minus -8, so 4 plus 8. Same thing down here. Now, both of them are a 1 by 3. So my answer is going to be a 1 by 3. 8 minus 3. 6 minus 5. And -4 minus -8, so -4 plus 8. I'm telling you, it's as easy as that. It's not a trick. That is just all there is to it. And then the last thing that we're going to talk about is you can multiply a scalar, so a numeral, by a matrix, and all you do is multiply the number by each element inside the matrix. So 5 times 2 is 10, 5 times -3, 5 times 0, and 5 times 4. Okay, so this one, 3/4 times 20. If you have to go up here and do your math, that's okay. 3/4 of 20, though. Hopefully we know that's 15. Okay. So 3/4 of 36. 3/4 of 36, 27. If you need to go up and do your math, hopefully we know how to multiply fractions, right? 3/4 of 12, the same thing, that's 9. And then 3/4 of -16, -12. Okay, and that finishes up the course. Let me know if you need anything at all. As always, talk to you soon.